All right, let's see what the first slide holds for us. So I know the numbers are kind of hard to see, but I'm gonna see if I can, write back the numbers. Here's what I need for everyone to do. I just, using a ruler, just draw a quick makeshift graph like on the screen. I'm gonna write the numbers bigger. Remember, your graph has an x-axis and a. All right, so we're kind of officially started, I guess, graphs for the first time in this class, right? In the Monday class, I kind of introduced the graphs. Now, here's the thing, right? Just to refresh your memory, your graph has two parts, the x-axis, which is the horizontal line, and then there is what? The y-axis, which is the vertical line. So your graph at the end of the day has an x-axis and a y-axis. I know some of you all have been out of school for a while, right? But usually when you draw a graph, right? Let's say the exam comes and you have to draw a graph. There are usually two categories of graphs. Some graphs, when you draw it, you get a perfect straight line, like this yellow line here. Just an example. So if we were to draw a graph, we could either get a straight line, or sometimes when we draw a graph, we can get the opposite of a straight line, like a curve. So there are two categories, and there are many different types of curves. And the green curve is just one example of a curve. So the first question I have for you guys, right? And let's write the word straight here. Which graph do you think would be easier? Like, which one would you prefer to get in your exam? The straight line or a curve? Which one naturally feels easier to deal with? Obviously a straight line, right? So me too, I agree. I would prefer if it's a straight line type of question. Before I move further with the straight and the curve, whenever they give you an equation, remember last week we were doing functions, it was fx or gx or hx equal to something. I think I mentioned that fx is the same thing as the letter y. So in other words, this y-axis, you can pretend it's the fx axis. I know it's kind of weird, but I did mention that last week, that fx and y is the same thing. So here's the thing. Whenever the examiner gives you an equation and he wants you to draw the equation, when you draw an equation, you can either get a straight line or a curve. There is an easy way to predict what shape of graph you can get. It doesn't work 100% of the times, but I would say safely it would work 99.9% of the times, which is close to 100, right? So how do you know, given an equation, if you are going to get a straight line or a curve? Very easy. Whenever your equation that they give you, when it only has simple things like y or x, you will get a straight line if you attempt to draw it. If your equation has fancy stuff in it, but this is what I mean by fancy stuff, like you have a y squared or a square root of x or x squared or an x cubed or x squared, or even the square root of y. Once you start to see fancy things like this, you know 99.9% of the times, you are going to get a curve. So based on what I just said, this equation that I am asking you to draw, remember fx and y is the same thing. I have just given you y is equal to 2x plus 3. Will I get a straight line or a curve if I attempt to draw that? Well, what do you all think? Will I get a straight line or a curve? It's definitely going to be a straight line because look at it, right? Remember, fx is the same exact thing as y. You have regular boring y and you have regular boring x. You don't see any x squared, square root, x to the power 3. This is just 2 multiplied by x. It's still regular boring x and regular boring y. So that means when I draw this, I'm supposed to get a straight line. Now, here's the thing. Drawing a straight line, like I mentioned earlier, is way easier than drawing a curve. To draw a straight line, technically you only need 2 points. Like you just need 2 points on the graph. And once you get the 2 points, you do what? You connect it using your ruler. But your teacher, and I agree with your teacher on this one, even though you only need 2 points to really draw a straight line, your teacher will say, get 3 points just in case. It's always safer to try to draw a straight line with 3 points. So here's what I'm going to do, right? I'm going to give everyone 20 seconds to take down this note if you want to take it down, but I need to erase everything in this section, because we're going to have to do some calculations in order to draw your first straight line today. So what's going to happen? When it comes to a straight line, you need to get your x values and you need to get your y values. Most of the times in the exam, right, the examiner will give you the x values. So the examiner will already choose the x values for you. So when you open the exam paper, pretend this is a past paper question. In this little table, the examiner has already chosen -1, +1, and 2 for your x values. Unfortunately, you have to calculate your y values, but it's going to be super, super easy because you all are really accustomed with functions already. So here's what you need to do. For the first one, when x is, let me get a different color here. When x is -1, you just have to go to the equation and replace x with -1. You think you all can do that for me? I just use the letter y. The letter y looks a little bit simpler for me. When x is -1, they want you to go to the equation and replace x with -1. Could you all calculate the value of y? Because when you replace x with -1 here and you work this out, you will get the corresponding value for y. Right? So Naomi, Jordan, a lot of different answers are coming up, right? Well, let's see what happens. Right? When I replace the x with -1, remember this x, I'm going to throw it away. And by now we know when we replace something in maths, we replace it in brackets. So I'll replace the x with -1. 2 multiplied by -1 is -2. And then we have to add the 3. -2 plus 3 is +1. The answer is +1. It's literally that simple. Now, let me do another example for you. In the next one, we have to pretend x is +1 in order to get the corresponding value for y. So we write back the equation. Y is equal to 2x plus 3. We are replacing x with +1 this time. How much we're going to get here? 2 multiplied by 1 is 2. 2 plus 3 is 5. You put the 5 here. You think you all can do the last one for me? You're going back to the same equation. And all you're doing is replacing the x with 2 this time. Right, running out of space here, so I'll clear up some space on top here. Right, so let's see if you guys got it correct. Right, so to calculate this value here, we pretending x is what? 2. Well, I can probably y is equal to 2. I'll replace the x with 2 plus 3. 2 multiplied by 2 is 4. 4 plus 3 is 7. So once you get your values now, all you have to do is plot it on the graph. So you have 3 points. all points consist of an x value and a y value. This is our first point, this is our second point, and this is our third point. So watch me plot these points on the graph. For those who know how to do it, you go ahead and do it. The first point is -1, 1. It's -1 on the x-axis and +1 on the y-axis. You go -1 on the y, on the x, sorry, and then you go up to +1 on the y. This here is the point -1, 1. The x value always goes first, the y value goes after. Let's do another one. The next one is 1, 5. 1 is the x value, 5 is the y value. So we go +1 on the x, and then we go up to +5 on the y. This here is the point 1, 5. Let's do another one. The next point, the third point is 2, 7. 2 on the x, 7 on the y. 2 on the x, 7 on the y. Look at it, hovering over 2 on the x, and it's in line with +7 on the y. This is the point 2, 7. If you all take your rulers and connect these points, will we get a perfect straight line? Well, I think we will get a straight line if we connect those 3 points. We will get a straight line. Because we're going to eventually spend an entire session dedicated to plotting graphs. The main thing I wanted to show you from this, right, is that I wanted to prove to you that whenever your equation has simple things like y and x, and you did the calculations to get the graph, you would get a straight line. How much of you all at least grasp that concept? Because I did say when you only had simple things like y and x, if we were to draw the graph, we're supposed to get a straight line. And my calculation showed that we did get a straight line. But that's the main point so far. Plotting it on the graph wasn't the main point of the class. But there's a fancy word for straight lines, and that word is linear. And that is why you're seeing that word on the screen. Linear means straight. A linear line is a straight line. Now, here's the thing, right? There are many types of straight lines, right? Think about it. Let me draw a little makeshift graph here. There are many, many types of straight lines. Let me draw x and a y-axis here. So the x-axis is the horizontal, the y-axis is the vertical. Is it possible? Always pretend you're looking from left to right, okay? Is it possible a line could slope upwards? Obviously. Isn't it also possible a line could slope downwards? Does everyone agree with that? A straight line could either slope upwards or it could slope downwards. But what else could happen to a straight line as it slopes upwards or downwards? Well, look at these two graphs here. Isn't one, let me keep the colors consistent. Like if this value here was 1, here was 2, here was 3, and here was 4. Keep your eye on the y-axis. Do both lines slice, right? Do both lines slice the y-axis at the same place? Look at it. Does the pink line slice the y-axis the same position as the y-axis? The answer is no. And look at it. The pink line is slicing the y-axis at +1, and the blue line is slicing the the y-axis at 3. So that's another difference between straight lines. Straight lines can slope upwards, they can slope downwards, and they can also cut the y-axis at different points. Now, I know what some of you all are saying already, and let me address it, right? How come I'm talking about the y-axis, but I did not mention anything about the x-axis? If I extend this blue line, isn't this blue line slicing the x-axis, which is the horizontal line, at a different point than the pink line? And that is truly another difference between straight lines. So let me just give you the 3 differences, the 3 scenarios or different scenarios between straight lines. If I ask you to draw a straight line, it could either slope upwards, it could either slope downwards. It can also cut the y-axis at different points, and it can also cut the x-axis at different points. But for some reason, and I don't know who came up with the rules, right? Remember, maths was, different people came up with different rules, and we just adopted one of them. Where it cuts the x-axis is not super important. I mean, it's important, but it's not super important, like where it cuts the y-axis and whether it slopes upwards or downwards. And here's the thing. Anytime I give you an equation, once you realize it's a straight line, you can actually predict whether it's going to slope upwards or whether it's going to slope downwards. And you can also predict where it will cut the y-axis. All of that even before you do your calculations. It's like being a fortune teller. And that is what we're going to investigate in the next slide now. Predicting the shape or the look of a straight line without doing any calculations. So let's go to the next slide here, right? You don't need to take down anything here that I just drew, right? Right. So this is the same graph that we just drew. I just drew it back neater. I use a computer program, and it's the same equation. Now, here's the thing. Whenever you have the equation of a straight line, like they ask you to draw the equation of a straight line, make sure y is the subject, not x. This means y must be on one side of the equal sign, and everyone else must be on the other side. Must. No exceptions. Here's how easy it is to figure out whether your graph is sloping upwards or downwards. Once y is the subject, look for the letter x. What number is touching letter x today? In my example, right? The number 2. Is that a positive number or a negative number? It's a positive number, right? Here's what, there's an official name for the number that touches x. His name is the gradient. And the letter that usually represents the letter gradient, the word gradient, for some very strange reason, is the letter M. I don't know who chose that. If it was up to me, I would have choose G. But they choose the letter M to represent the word gradient, right? The gradient, if you go in the English dictionary, right? Gradient means how steep something is, like a mountain. And when you climb up a mountain has a certain steepness. A hill has a certain steepness. And like all mountains can either go up or go how? Down, right? Here's the thing. Anytime the number touching x is positive, in other words, when your gradient is a positive value, look down here. Your line will always slope or upwards. You can bet all your money on that. And if the value touching x, better known as your gradient, is a negative value, you can bet all your money when you draw it on a graph, it will slope downwards. So that is why even before I drew the graph today, I knew the line was sloping upwards. Isn't my line sloping upwards? Because I just have to look at the value of the gradient and I saw, hey, the gradient was positive too. So I knew that after I drew the graph, I was going to get a line sloping upwards and not sloping downwards. But what about the number that's not touching x? So the 2 is touching x. His name is the gradient. The guy who is not touching x, his name is the y-intercept. And the value for the the letter used to denote the y-intercept is C. It's not the letter Y, it's not the letter I. Okay? The y-intercept just tells you where it cuts the y-axis. That's a fancy term, you know. Why to intercept something means to cut off something. So you all notice what the value of the y-intercept is in my question today. Isn't it 3? Did it not slice the y-axis at 3? Look at it. It sliced the y-axis at 3. Everybody okay so far? I don't expect it on 100%, but at least, let me call it 50%. You think 50% of that makes sense so far? All I'm doing is trying to get you to predict how your straight line would look before you draw it, right? There'll be plenty more examples, plenty of me repeating the same thing over and over and over. All right. All right, so here's our let's call the good guy in the story, the protagonist of our story. So our friend Assad, you know, he has now moved to Spain from Morocco. He found some discarded barrels and he's selling fruits. So let's see his first customer, and you're gonna help him sell these fruits here. This is our first customer here. Hey, this guy looks familiar. Anybody know this guy? Right? He seems to be low on cash, but all you didn't know, that's Mark Zuckerberg, but according to Assad here. So he's so happy to see Mark Zuckerberg. Which one do you think he should sell, guys? Should he sell the apples, the bananas, or the watermelons? Or which one do you think will, you know, give him the most passion? Right, so which one Mark is going to, you know? Hey, most people going with the bananas. All right, I'm playing the game too. I made this, I can't remember. I'm going to go with the watermelons. I like watermelons. All right, let's see how much money we get and write down how much money you get, right? For those who chose apples, write down 40. Bananas, 50. Watermelons, if that's a real word, $3. And we're going to see how much we'll have the most money at the end of class. All right, so let's be on our way. Let Mark Zuckerberg go his way. All right, so here we're going to work this question backwards now. Remember at the beginning of the question, right? I gave you the equation of the line. And when I gave you the equation of the line, you were able, with me, together, we were able to draw the straight line. Let's say something happens now. Let's say for some strange reason, this gets erased and you cannot remember the equation of the straight line, but the examiner has given you the graph. How can you get back the original equation? Well, we look at this and say, hey, it's a straight line. That's our first tip off. All straight lines have this general look. All straight lines have y, you just call it y equals to mx plus c. That's why the name of this topic is also called y equals to mx plus c. M is your gradient, and he will always be touching X. And C, like I mentioned before, is your y-intercept, and he will not be touching X. You see, when you're trying to find back the equation of the straight line, you have two jobs. You have to find the value of M, and you have to find the value of C. There are two ways to find back M, and there are two ways to find back C. Well, I'm obviously going to do it one way, the way that I'm accustomed with. Here's how I do it. I find it one at a time. And I always find M first. Always, no matter what. I always find my gradient first. And then I find what? C. Please do not attempt to find your y-intercept first, right? So let me show you how to do this question. I want everyone to take down this formula. To find the gradient, well, I used a yellow there, sorry about that. To find the gradient, you have to memorize this formula. Y2 minus y1 divided by x2 minus x1. Just take it down, and I'll show you how to use the formula. It's going to be very easy. And remember, the symbol for gradient is the letter M. The letter I do not approve of, because I would have chosen G. Right. So here's what we need to do now. To find the gradient, according to the instructions here, you need to choose 2 points on the line. The thing about it, and let me know on the chat here, right? If you have a whole Caribbean exam and you give everybody a graph, do you think everybody is going to choose the 2 same points? Well, what do you think? You think the people from Jamaica is going to choose the same points as the people from Trinidad? Or even if you're in Trinidad, you think the person next to you going to choose the same exact 2 points as you? Obviously, no, right? So I want to get that off the table one time, because I know from teaching, somebody is going to ask, doesn't matter which 2 points we choose. And what if 2 people choose 2 different points? Will we get the same answer? The answer is yes. Everybody is going to get the same answer for any 2 points that they choose. But you have to be smart. You have to choose 2 points that are easy to identify on the graph. Like this point here. Do you all think that that is easy to identify? Look at it. Isn't it X? Isn't the X value 1? And isn't the Y value 5? Like, you can be sure that's the point 5, 1. Well, 1, 5. So this point here is 1, 5. You just always put the X value first and the Y value second. Everyone do that for me, right? It doesn't draw a makeshift graph here. You can do this one freehand, right? And just put this point and put the brackets and the 1 and the 5. What other point do you think is easy to identify? And this one looking like it's real easy to identify, like it's whole numbers and you can be sure about it. Well, what's the value of this point? Anybody wants to take a guess? What's the value of this point here? Like, yeah, Terrell, that would work also, but just choose the one I'm using to make it easier. But you're correct. Right. Isn't this the point 2, 7? Remember, you have to put the X value first and the Y value second. So here's what we're going to do. We have 2 points. I'm just going to call it A and I'm going to call it B. You can call it anything you want. If you want to call it P and Q, fine. Doesn't matter. The first point you choose, but the first point I chose was A. Doesn't A have an X value? And doesn't A have a Y value? I think I clearly mentioned the X comes first and then the Y comes after. Because you chose A first, everything in A will have the subscript 1. So this is X1 and this is Y1. Didn't I choose B second? So this comes like X2 and this comes like Y2, because this is the second X coordinate I chose and this is the second Y coordinate I chose. All we have to do now is throw it into this formula here. So I'm running out of space here. So I'm just going to put M for gradient here, right? You think you all could work out the gradient for me? Replace y2 with how much? 7. Replace y1 with 5, right? x2 with 2 and x1 with 1. All right, so I think I know the mistake some people are making. You cannot type in this straight on your calculator, unfortunately. You have to work out the top separately, work out the underneath separately, and then divide, which you'll get accustomed with. So how much is y2, guys? So look at the formula here. y2 is 7. According to the formula, I must put a minus. I must put a minus. y1 is how much? 5. x2 is 2. According to the formula, I must put a minus sign. And x1 is how much? 1. Let's work this out. 7 minus 5 is 2. 2 minus 1 is 1. Isn't 2 divided by 1, 2? You see, if you type it in straight on your calculator, you'll get some weird answer. Whenever you have a divide, like something on top and something underneath, work out the top separately, write it down. Work out the underneath separately, write it down. Otherwise, your calculator will misinterpret it, unless you're really good at using a calculator. For those who did not get 2, did you see your error? Look, I needed to watch through the working, right? And match up your working with my working and see the spot your error. Right? Because about 5 people got it wrong, just confirm with me. Right. Now check this out. Isn't the gradient supposed to be 2? Look at it. Weren't we supposed to get 2? Look how we backtracked and got the 2. Right? So there is a way to backtrack and get the gradient. So here's what we know so far. We're not finished, eh? I'm going to show you how we could get back the number 3. So this is what we know so far. Y is equal to mx, the value of m. We just figured out it was 2. So I throw away the m and replace it with the 2. And we still have to figure out that we still have to figure out the value of c. To find, right, the value of c, look at the pink note here. Once you have the gradient, and we have the gradient, choose any point on your line. Any point. It doesn't matter. It doesn't matter if somebody in Jamaica choose a different point to you in Trinidad. Which point? Well, we have 2 points here. Which one you all want to choose? A or B? Let me just vote on it. A or B? Which one you want to choose? Anyone is going to give us the same answer. It's like magic. Let's go with A. All right, let me go with A. So we choose an A. That's our choice. Huh? According to point A, how much is Y? Isn't Y 5? And how much is X according to A? 1. So we go to the equation and we make that substitution. We said, according to our chosen point, Y is 5 and X is how much? 1. So I'm going to replace the X in brackets there. You think you all could solve for C? Everyone should, instead of solving for X, we're solving for C. So everyone should be able to solve for C by now, because remember, you had 8 questions for homework on how to solve for a letter. And let me know if you get back 3, because the y-intercept is supposed to be what? 3. Right now, a lot of people are telling me, hey, they're getting back that 3, which is good, which is what you're supposed to get. So you have 5 here. 2 by 1 is 2 plus C. Well, throw across positive 2, you get minus 2. Obviously, we're going to get what? 3 here. And that's the 3 here. Now, somebody brought up a very good point, right? Check this out. Isn't C the y-intercept? So couldn't we just watch the graph and figure out that the y-intercept was 3 instead of choosing a point, substituting it in, and getting 3? Which one do you think would be easier? To do this crazy piece of calculation or to watch the graph, right? And figure out that the y-intercept, where it cuts the y-axis, is 3. Obviously, to watch the graph, right? But here's the thing, right? The reason I showed you the long way, sometimes when the examiner draws the graph, he will intentionally leave out the y-axis. Like, so even if you look for the y-axis, you can't find it. So you can't visually see where it cuts the y-axis. So you're forced to do what? Calculations in order to get it back. And that's very common in the exam. The y-axis will be magically missing, but he will give you the 2 points. Like he will put the 2 points here, A and B, and he will do what? Write out the values of A and B. But the y-axis, it will be missing in some cases. So I hope that answers the question. And of course, I'm glad you asked the question. Take down everything on the screen. Just to summarize, this was how to work backwards, given the graph, how to get back the original equation. Right, let me know when you're finished. I will move on to choose. Remember, when it comes to finding C or your y-intercept, right? It doesn't matter which point you choose. You could either choose point A or you could choose what? Point B. You think if we choose point B, we're going to get back the same answer of 3? Well, let me prove it to you guys, right? And because I think some of you are a little fidgety, like you can't believe it unless you see. So if we chose point B, remember, according to point B, X is 2 and Y is 7. So let's do that. So if we say somebody in Jamaica decided to choose point B. So according to this, Y is 7. And according to our chosen point, X is 2. Look at it. I replace the X with 2 and I'll make sure I put my brackets. 2 multiplied by 2 is 4. And when we throw across positive 4, we'll get minus 4. And 7 minus 4 is 3. And we still get back Mr. 3. It doesn't matter which point you choose. You will get back the same answer for the y-intercept. You don't have to take this down. This is just for me to prove a point. Right? So how much of you are feeling a little bit easier that you saw it for yourself now? It doesn't matter which point you choose to find C. This is after you find your gradient, because we're always going to find the gradient first. All right, so let's move on. So to find out where something cuts the x-axis, that's the horizontal line, the instruction said, I'm going to write back the equation here. Y is equal to 2x plus 3. The instruction said, go to the equation and replace Mr. Y with what value? 0. So let's do that. Replace the y with 0. And all we have to do now is solve for x. Because when you replace the y with 0, the only letter that's going to be left automatically is x. Could you all quickly solve for x? This is your transposing based on worksheet 3, videos 5, 6, and 7. Solve for x and let me know what you get. You can put your answer as a decimal or a fraction. It's really up to you. Right, but a lot of people are getting minus 1.5, but let's make sure you're correct. If you want to solve for x, you want to get x on one side, we know everyone else on the other side. You can just throw across positive 3. Positive 3 becomes what? Minus 3. This 2 is a multiply. Throw across a multiply, you get a divide. So you could leave it as minus 3 on 2, but if you use the calculator, minus 3 on 2 is minus 1.5. It's actually supposed to be exactly minus 1.5. It's a real simple procedure. Just replace x with 0, solve for x. And that will tell you exactly where the line cuts the x-axis. Take a 20 seconds, take down what you need to, and we will move on. Let's move on. It's our friend Assad here again. But this time he's selling pears, carrots, and lettuce. let's see who his next customer should be. Hey, it's this guy here. So apparently some bad guys are after him because he's been given a really hard and impossible mission. So he needs something to distract the bad guys. So I'm going to play with this one too. I'm going to go with the carrots. Yeah, I think the carrots will be an excellent choice. I like hear what Assad has to say. Hey, this is, well, obviously, guys, this is Will Smith, right? And Assad has seen all his movies, Men Who Wear Black and Terrible Boys Part 1 and Part 2, and he asks for an autograph. Right, update your scores here, guys. Here's Titty, carrots, 50, and cabbages. Will Smith doesn't want cabbages to fight off bad guys. It's just $10. Let's go. Finally, a new equation. I'm sure you guys are relieved, but don't begin to draw anything as yet. I'm sorry, don't do any calculations as yet. I just want you to draw up a blank graph paper. Let me write back the values a little bit bigger. I know it's hard to see. It's a program I'm using. 1, 2, 3, 4, 5, 6, 7. Here's +1, +2, +3, +4. Here's -1. Everyone just draw up a blank graph there for me. And we're only going down to -1 there. Like I said, for those who now came in, I realize some people now came in, you don't need graph paper. So they ask us to draw this again. Let's do some predictions before we start any calculations. And if the fx is getting to you, remember I said you can just erase the fx and put the letter what? Y to make it easier on the eyes. All right. Let's predict how this line will look. Will this line slope upwards or will this line slope downwards? What do you all think? Let me write back the equation a little bit bigger here. Right, so this line, right? Remember, whoever is touching x is your gradient, and the letter for gradient is the letter M. And whoever is not touching x is your y-intercept. Now, this only works, like what I'm saying only applies if y is the subject. Now, lucky for you, y is the subject, meaning that y alone is on one side and while everyone else is on the other side. If you look back in your notes, whenever your gradient is negative, whoever touching x is your gradient. When it's negative, we said the line would slope downwards. So you can look, for those who got it wrong now, just look back in your notes. The line is supposed to slope downwards when we do our calculations. And it's supposed, if we do our calculations correct, it's supposed to cut the y-axis at 6. That's over here. So hopefully, when we finish with our calculations, it will look like our predictions. It's going to slope downwards and slice the y-axis at 6. Let's begin our calculations. But you'll notice a subtle difference between the first question and this question. You'll notice the table. In the first question, did the examiner give us the x values? What do you all notice, or what do you all remember? In the first question, were we given the x values? Yes or no? The answer is yes, right? Now, the examiner can either be nice or the examiner could be difficult. Sometimes the x values will be given and sometimes it will not. If the values are not given, guess what you have to do? You have to select your x values. But the question always starts with you getting these x values. Now, you have to be real logical about this. You go to your x-axis. You could choose anything for X, and like it's magic again. If somebody chooses 1,000,000, somebody chooses 3, somebody chooses 8, when you draw the graph, it's going to look the same. But you got to be logical. Do you think it's okay to choose 5 according to our graph for X? Do you think it's okay to choose 5? The answer is no. Look at our x-axis. Our x-axis only goes up to 4. So if I choose 5, how is my point going to fit on the x-axis? So the moral of the story is this. Look at your x-axis and choose 3 values you're seeing on your x-axis. I know what most people do. They're seeing 1, 2, 3. So they say 1, 2, 3. And that's perfectly okay. You're allowed to do that in the exam. If somebody choose -1, 2, and 4, they will get the same graph. Believe me. But let's just keep it simple. Let's just choose 1, 2, and 3. Do you all think you all can calculate the corresponding y values now? See if you remember what went on at the beginning of class. All you have to do is go back to the equation and replace x with 1, then replace it with 2, then replace it with 3. You could choose 0 if you want to choose 0, 2, and 3. Yeah, you can do it. You're allowed to choose 0. 0 is a number like any other number. So the examiner gave us the equation, right? In the first one, you have to pretend x is 1 to get the corresponding value for y. So I'll go to the same equation, replace x with 1 in brackets. -3 by 1 is -3 plus 6. -3 plus 6 is +3. The first answer was +3. In the next one, you have to pretend x is 2 to get the corresponding value of y. So you go back to the same equation. Replace x with 2 this time. -3 by 2 is -6 plus 6. -6 plus 6 is 0. All right, so let's have a look at the last one. You have to pretend x is 3 to get the corresponding value of y. Replace this x with +3 plus 6. -3 by +3 is -9, and then we have to add the 6 -3. That's -3. Is that -3? All right. All right, so I think we're running into a small problem here, but okay, right? But we'll see what the small problem is. Let's begin to plot our points, right? So one of our points I think is not going to fit, right? So the first point is 1, 3. 1 on the x and 3 on the y. All right, try my best to approximate it here. That's the point, 1, 3. The next point is 2, 0. 2 on the x, but 0 on the y. So you're not going up and you're not going down. This here is the point, 2, 0. He's on the x-axis himself. But can the next point fit on what the examiner has given us? Can the last point fit? The answer is no. Look at this. This point is 3 minus 3. So I go 3 on the x-axis, and then what? I have to go down to -3. But my y-axis only goes to -1. So it cannot fit. Now, this is a very popular scenario in the exam, right? Where you choose the 3 values, and then one of them can't fit on the graph. What do you all think you should do? Give up and cry, or choose a different value for x and hope that value of x will give you a good value for y. So all we have to do now is go back to the drawing board and say, all right, when x is 3, it gave us a value for that could not fit. Now, it just so happens, I don't want to waste too much time. I know which value we have to choose. We have to choose 0. Could you all choose x as 0? Nothing wrong with choosing x as 0. When x is 0, what's the corresponding? How much you're getting? Right. Right. You see, this is a little bit of trial and error, right? There's no technique to know whether your value is going to fall off the graph and it's not going to fit. It's a little bit of trial and error, right? Unfortunately, it is trial and error. So we replace the x with 0. Anything by 0 is 0 plus 6, and we get in 6. Yeah, man, 6 token. So you get 6. 0 on the x and 6 on the y. 0, 6. 0 on the x, 6 on the y. Take a ruler and join these points. Do we get a kind of, I don't have a ruler here, so I hope your graph looks a little bit better. Does this fit our description? Didn't at the beginning of the question, did we not predict the line would slope downwards? Look at it, our line is sloping downwards. And we predicted it would slice the y-axis at 6. And look at it, it did slice the y-axis at 6. So our prediction is correct. You see, when you have a prediction and then you do the calculation and the calculation matches your prediction, you know you 100% correct. You can walk out that exam smiling. You don't have to wait for anybody to show you the correct answer before you realize that you're getting marks in the exam. You predicted and then you got what you predicted, right? Now look at this. See if you all can remember this. Do you all notice where it cuts the x-axis? Where is my graph cutting the x-axis? Listen to the question. Where is it cutting the x-axis? What's the value of where it cut in the x-axis? At 2, right? But let's say the examiner wants you to use calculation to prove that it cut in the x-axis as 2. You think you all can remember how to do this? Let's write back the equation here. Y is equal to minus 3x plus 6. Without looking back in your notes, whenever you want to figure out where it cuts the x-axis, do you replace the y with 0 or the x with 0? Without looking back. See if you can jog your memory a little bit. When you want to figure out where it cuts the x-axis, do you replace the y with 0 or the x with 0? Yeah, I know some of you are going to mix it up. Is actually replace the y with 0, the y with 0. I know that you're trying to figure out where it cut the x-axis. So naturally, you might say, well, we're going to replace x with 0. No, you replace the y with 0. And if you don't believe me, look back in the note. The note said to replace the y with 0. So everyone replace the y with 0 and solve for x. And tell me if you get back positive 2. If the x-intercept by calculations is actually positive 2. But see it for yourself. Just don't take my word for it. Right? Now, if you're solving for x, you're throwing across who first? Positive 6. When you throw across positive 6, you get minus 6, right? And then the minus 3s are multiplied, throw across minus 3. Well, multiply, you get a divide. 6 divided by 3 is 2. And when you divide 2 minus, you get what? A positive. So yeah, we get back the positive 2. I think some people type it in wrong. Instead of typing in 6 divided by 3, it has slipped by mistake and said 3 divided by 6. Good, Cameron. Good, good. Somebody said they finished. Right. Do you all think you all can work backwards now and get back the original equation? We're going to pretend that you don't know the equation is y is equal to minus 3x plus 6. Let's say some water fell on the paper and smeared it, and you want to work backwards. I'm going to give you all 5 minutes just to try to work it backwards. I'm not saying you will get it correct, but just try your best now. Work back and see if you can get the gradient as minus 3 and see if you can get the y-intercept by calculations as positive 6. Now, I don't know which 2 points you all chose because I gave you all 3 to choose from. I'm going to choose this one here. His point is 0, 6, not 6, 0, because it's 0 on the x and going up to 6 on the y. You just always put the x first and then the y. If you all chose this point in the middle here, he's pretty easy. Also, he is 1, 3. Right? So choose any point first. I'm going to choose the one on top first. So he is x1 and y1. Whichever point you choose first or you decide to point to first is x1 and y1. Making the other point x2 and y2. So let's find our gradient, right? We'll clear up some space here. To find gradient or the letter m, it's y2 minus y1 divided by x2 minus x1. Let's throw it into the formula here. Where y2? Y2 is 3. I must put a minus sign. That's part of the formula. Y1 is 6. X2 is 1. Right? And what's the other one? X2 and x1 is 0. I think I have it correct there. I was making sure, guys. Y2 minus 1 divided by, yeah, I have it correct. My substitution is correct. 3 minus 6 is minus 3 because it's 6 bigger than the 3. 1 minus 0 is 1. And by now we know minus 3 divided by 1 is minus 3. Look at it. We got back what? Minus 3. Right? And remember, if you choose 2 different points, you're going to get the same thing. And remember I said, it doesn't matter if you choose this point, or this point. And this point here is supposed to be 2, 0 for those who choose this one. You're supposed to get positive 3. Check it back, guys. You're supposed to get negative 3, not positive 3. If you got positive 3, check back your working, right? Make sure you're seeing negative 3 and do not settle for positive 3. Those 2 things are not the same thing. Great. So this is what we know so far. The equation of any straight line is y is equal to mx plus c. We just found m. So why put m? Put what we just found. And we just found out, m is, oh, that's a horrible color. I'm looking for good colors here. Minus 3. We just need to find c. To find c, you choose any point on your line. I'm going to choose this middle one here. Just to make it a little bit more difficult so we can understand it a little bit better. According to the point I am choosing, and I can choose any point, x is 2 and y is 3. So I go to the equation. According to my chosen point, y is 3. Look at it. Y is 3. X is 1. Minus 3 by 1 is minus 3. Let's solve for C. Throw across minus 3. Bob, look at it. And we get 3 plus 3, 6. Isn't my y-intercept supposed to be 6? So I can work it backwards. If they give me the graph, I can get back the equation. And if they give me the equation, I can draw the graph. Examiner kind of trick me now or tie me up. I can do it both ways now. Right, so you have 20 seconds and we're moving on. All right, so one even Assad decides to go forward, right? He needs a little break and whatnot. And to his surprise, he finds a missing dog and it belongs to Lionel Messi. How lucky of him. Right, so that's Messi there walking with his dog. Of course, Messi will reward him here. You know, it's a color, guys. A little reward money for recruiting here on the dog there. Red, blue, or green. Speed for all the dogs. I'm feeling lucky with red. I'm gonna do the red. Well, I didn't choose the best one, but the red colors, that's our reward. Green, SPK gives you nothing. Alright, so let's move on. Oh, well, Messi says everything is faster coming home country. That when you see the dog, they give you a football. Use a football, they have to some extra money. First, second, or third. First, second, or third. I'm feeling lucky with the middle football though. Oh Lord, the third one was the best one. The third one was 15. I chose the middle one. Nah, only $5. All right, guys, let's move on to the next slide. All right. Well, this one here, let's do this one quickly. It's pretty easy. Or no, I think we did this one already where I made you prove that the x-intercept was 2. So let's not do this one. We just did this one. Sorry about that repeat question. All right, now I have a trick here for you, a kind of trickish question. I want everyone to draw this graph here. We might go a little past 8:30, right? Because I want to finish this one, right? This at 5-10 minutes past, right? But I need to finish this. I can't start this and not finish this one. Draw this graph for me, a blank graph here. So they gave us an equation. If I were to draw this equation, will I get a straight line or a curve? Let's get that out of the way first. Right, we're still going to get a straight line. The reason is, right, that there's nothing fancy in this question. Remember, for a curve, you're supposed to see fancy things like x squared, x cubed, square root of x, square root of y, y squared. When it's regular, boring y and regular, boring x, it's going to be a straight line. There's nothing fancy in that question, but that equation so far. So we reason it out. We gain a straight line. All straight lines must have a gradient and it must have a y-intercept. How much is the gradient? And how much is the y-intercept? Remember, I showed you all this. The equation of a straight line is y is equal to mx plus c. Whoever is touching x is your gradient, and whoever doesn't have the x is your y-intercept. So quickly, how much is the gradient and y-intercept of my new equation? right? And guys, I'm trying to trick you all here, right? How much of you all, be honest with me, right? I see the answers coming up. Remember, whoever touching X is supposed to be the gradient, right? So if you look at X here, the 2 is touching X. So the gradient is 2. By the way, if you're saying the gradient is 2, you have to say the gradient is 2, not 2x. Whoever touching X is the gradient. And whoever doesn't have an X is the y-intercept. So you might be quick to say that the y-intercept is 10. But this is 100% wrong. 100% wrong. If you look back at the notes properly that you took down, you are only able to extract the gradient and y-intercept if y is the subject. It only works if y alone is on one side and everybody else is on the other side. Is that the case here? Is y the subject? Yes or no? Is y the subject at the moment in our current question? No, right? So the answer is no. So you cannot extract your gradient and y-intercept. It might be tempted to do it, but it's going to be wrong. So what you have to do, unfortunately, you have to use your transposing skills. So let's use our transposing skills and make Mr. Y the subject. To make y the subject, who do you throw across first? And you're from the homework, right? And you'll throw across the positive 10 first because we're trying to get y on one side. So throw across positive 10, you will get minus 10. You cannot subtract 10 from 2x. You learned that already because x have a letter, the 2x has a letter, and the 10 doesn't have a letter. Who is next to throw across? This 2 here. This 2 is a multiply. Who do we divide on this side by the 2? The first, the 2x or the 10? Which one do we divide by the 2 that we're now throwing across? Let me see if you'll fall for this trick. Guys, well, most people are getting it correct, right? Remember, well, there's 2 ways to explain this. You're supposed to divide the whole thing by 2. You have to be fair. If you're throwing across the 2 and then have 2 people waiting there, you have to divide both of them by the 2. But you can also write it like this. You have to divide him by 2 and him by 2. You divide both people waiting on the other side by 2. Remember that from the homework, it was clearly expressed. Right? So once we simplify this now, 2x divided by 2 is, well, the 2 and the 2 will cancel out to give you x. And 10 minus 10 divided by 2 is minus 5. Now tell me something. Usually there's a number touching x. If you don't see a number, what number is automatically there? Do you think it's a good idea to write it in? Yes, it is. Writing the 1. Can you all tell me what's the gradient now? How much is the gradient and how much is the y-intercept? Right. The gradient is 1 because whoever touching x is the gradient and whoever is not touching the x is the y-intercept or the c value. M is the gradient, c is the y-intercept. And only now, so, and we can predict the shape of the graph. Will this graph, when we draw it, will it go up or will it go down? Because only now, at this point in the question, we were able to extract M and C. Is the graph going to slope upwards or downwards? And it's going to slope upwards because isn't your gradient 1? Isn't 1 already positive 1? So it's going to slope upwards. And it's supposed to cut the y-axis at minus 5. So it's supposed to cut somewhere down here. Look where the pencil is. It's supposed to cut somewhere down here. All right, when we finally draw it. All right, so let's get some values. So this is the equation we have to use to draw our graph now, the one where y is the subject. He is the important one. The original equation where y is not the subject, we don't care about here again. Let's quickly choose 3 values for x. Remember I said, when the examiner doesn't give you 3 values for x, you go ahead and choose 3 values. So let me help you guys out here. Let me choose 0, 2, and 3. You think that's manageable? 0, 2, and 3. You're going to this equation, replace x with 0, calculate y. Replace x with 2, calculate y, and so on. And then plot your graph and tell me if it really, really goes upwards. The first one, we're replacing the x with 0, right? So let's not pretend we have 0 here. 1 multiplied by 0 is 0. Anything by 0 is 0. 0 minus 5 is minus 5. Then we can replace it with 2. 1 multiplied by 2 is 2. 2 minus 5 is minus 3. And then if we replace the x with positive 3, 1 multiplied by 3 is 3. 3 minus 5 is minus 2. How much people could agree with those answers? A lot of people did get it and they sent it. Right? Right, this one was easy because we was multiplying by 1. 1 by anything is itself, right? So all you have to do now is plot the graph, right? And see if it actually goes upwards. So let me get a different color here. Red, the red shows right good. The first point is 0 minus 5, right? 0 on the x, and we go down to minus 5. That's somewhere down here. 0 minus 5. The next point is 2 minus 3. 2 on the x, and you go down to minus 3 on the y. So that's 2 minus 3. And the last point, 3 minus 2. 3 on the x, and you're going down to minus 2 on the y. Yeah, I think when you join up those points and they're going upwards, yeah, they're going up. If you continue the line, you can see it going upwards, right? It's an upwards graph, and look at it. It's slicing the y-axis at minus 5 as predicted. Your prediction matches up to your calculations. Class. Let's go. All right, so we have a little cut scene here. So next week, we're going to continue the story, right? It has to do with start seeing a robbery in progress while sleeping on the streets. And of course, you know what happens? He gives him a warning. Assad does his smart thing and says, yeah, I didn't see anything. So anyway, next week in class, we're going to start off from this point. We have a lot more to do in our programming. Linear equations, right? And that's it for class, guys. All right. For those who don't know what the homework is, stay back here. I'll gladly explain it, right? But the most I have to do is stay back and explain it, right?